Ooh, that might be kind of loud. Let's turn it down a little bit. There we go. Good morning, everyone who is tuned in right now. We're gonna delay until 9:15, just so other people have a chance to check the Google Classroom, check their email, and join the stream. So if you guys are already here, thank you very much. Um, but just hang on about 15 more minutes and we'll get started. All right, we're just about ready to get started. But let's listen to the chorus one more time. All right, thank you very much to Portugal the Man for stopping by my home and playing songs for you guys on stream. Good morning, everybody. Let me make sure I'm all set up right here. Got the chat out. Okay. Since you guys should all be on Gmail accounts, you should be able to chat in the stream channel. And if you have any questions, if you have any answers, uh, or you want to provide an answer or share something, you can do that in the chat. Um, so yeah, it's in a good place right now. Right here, I am on the MobiMax sign-in page. I'm gonna go ahead and just quickly go through how to log in. So once again, if you're on the sign-in page as a student, you should have your username and password. I sent those out last week. But let's say it gives you this page and it tells you that you have to find your school first before signing in. Well, our school name is Village Glen. We've hit find, and then there's two options. There's the Los Angeles version, the Sherman Oaks version. We're at Sherman Oaks, so we're going to click this one. And now it'll give us the regular login. So make sure we're logging in as a student, not as a teacher, a parent, an admin, or another admin. I'm going to just go ahead and type in my info. Again, I'm not too worried about showing it. I don't really use this other than to see if the things I assign actually show up. Okay? So it takes me to this page, this assignments page. Mine looks a little bit different because I also use this account for math, so it's going to have some math lessons here. I assigned a lesson on animals. There's two parts to it. I assigned part one last week, and that will be due on Wednesday. But it's not listed here in the assignments page. It's actually listed, well, actually, it's just automatically queued in your guys' assignment feed or your sequence. So you have to go and click this left icon right here, the one with the books, and go all the way down here to the little Erlenmeyer flask that says science, and you're going to click it, and it should take you straight to the lesson. Now, I've already gone through some of the early pages. Here are all the parts to this lesson. And if you guys need more time, for instance, if you weren't able to access the Google Classroom or you didn't check your email or there was some problems with your devices, that's fine. I'll extend the due date a little bit longer, but I will be assigning part two on Wednesday. So make sure you guys don't delay too much on completing this stuff. We're going to try to keep going as normal. So please, please, please try to stay update and caught up with everything. So let's go through and let's just start. I'll do some of this, some of the lessons so you guys can see what it looks like. Every single one of these pages has diagrams, different informative text, and you might get asked questions. You might just be asked to read on a different slide. This one is a little bit different. You have to sort these out. Okay, so we are given a list of animal characteristics, and then we're given in white these little boxes with traits on them. So we have to figure out how to match the characteristics to the trait. Okay, so if I'm thinking about what helps an animal obtain food or consume food, I'm thinking, something like teeth, all right? Uh, Building nests doesn't really help you obtain food. Gills don't help you obtain food. Kidneys don't help you obtain food. So it's gonna be teeth right here. So I'll put teeth right here. Oh, and it's correct. Maintain homeostasis. Now we haven't talked about homeostasis in a while. Back when we first talked about characteristics of living things, but homeostasis, in case you guys are unfamiliar or don't remember, it's just making sure that the internal conditions of an animal's body are kept stable. Okay? So this is things like temperature, okay, the amount of water inside your cells or inside your body, the amount of sugar in your bloodstream if you're an animal. I mean, those are all things that are constantly changing. And so a lot of what your organs do, organs like lungs, heart, and different organ systems, they help to maintain the stable internal conditions. So of these four things, the only thing that I can see that maintains stable conditions would be these kidneys removing excess water. Okay, I just mentioned a little while ago that sometimes things that like temperature and the amount of water need to be maintained. So this one seems like the right choice for this characteristic. In terms of movement, well, we have three options left, and of these three, I think fins are the ones that help movement the most. For reproduction, I think a nest is most suitable, most appropriate for this characteristic, because nests are built for, well, animals build nests so they can have a place for their young to be born and develop. And finally, gills. We already know this from our fish unit, but gills are used to obtain oxygen from the water. Okay, and looks like we're good. So this is just an example of one of the pages where you have to complete like a little list or a little problem in order to progress to the next one. Uh, and it'll give you some information here. Let's go to the next one and see what it looks like. Explain why humans are classified as animals. Okay. Well, This is gonna be interesting. So, what you guys will have to do most likely is try to take notes on the pages beforehand. But I'll go ahead and explain why we're classified as animals. There's no multiple choice here, just to write your answer out. Uh, but let me see if we can just do this. Let's do a bullet point list, okay? Explain why humans are classified as animals. Well, let's see. Humans are classified as animals because here we go. They are multicellular. We're made of more than one cell. Okay. We have specialized tissue. So things like teeth, cardiac muscle, the muscle that makes up your heart, nerve cells. Those are all different types of cells, and they make up different types of tissues for our different organ systems. So uh, I've mentioned this a lot, but it's coming back again. Specialized tissue. We reproduce. Okay. What else? We move. Perfect. Well, we should probably change this all to we, because we are all humans. And you can list more reasons. Let's go ahead and keep it to at least three. Let's do one more. We produce. All right. We consume food. Okay. We consume food. So these are five good reasons as to why we're classified as animals. And let's keep going. Check for understanding. All right. So this part is simply a simple sort of checklist that goes over what we was reviewed. Okay. And you just click on these red boxes and it gives you sort of the key points of what we just covered. All right. So all animals have the same characteristics: multicellular, specialized parts, movement, reproduction, obtaining food and oxygen, and maintaining homeostasis. Remember, homeostasis is the ability to maintain stable internal conditions, so conditions inside your body. All right, let's move on. How are animals classified? Ooh, we are covering this in my other biology classes. Classification is a really interesting part of biology because there's so many different types of animals, and the way they're classified, looks and examines their body types. It examines sort of their genetic or evolutionary history, and it's really cool when you step back and see the big picture, uh, how organisms are related to each other. Okay, so let's listen here to what they have to say on this particular slide.
Scientists estimate that there are at least 7 million species of animals on Earth. Only about 900,000 of those species have been identified and categorized. Because there are so many species of animals, scientists need a way to classify, or group, all of them.
All right, perfect. So if you guys want to ever get in the field of biology, just remember that uh, we we need people out in the field to catalog and classify the other 6 million species out there. Okay. So the main process of classification, it's written right here. We examine how closely related animals are. So we could put them into groups, and the more closely related, the smaller of a group they'll be put in. Um, which is stated right here. So the more similar two animals are, the more closely they are grouped. Um, but again, the classification system was developed way before things like genetic testing, molecular clock testing were around. So over the years, animals have had to change groups as we developed more sophisticated systems to classify them. So the first thing we obviously start off with is it living? If an organism is living, then we can categorize it in one of the groups. or sorry, we can classify in one of the groups. If it has a eukaryotic cell, a cell with a nucleus in it, then that narrows it down. So if we're looking at these groups, living organism, this group would include anything that's alive, from a bacterium to a small parasite to a blue whale. I mean, they're all part of the same group of living organisms. But then we break it down and we say, okay, I only want to look at the living organisms that have nuclei in their cells. Well, that eliminates a lot of different species. There's a lot of organisms that do not have nuclei. So already we've made a smaller group. And the smaller group is more similar to each other because they all have nuclei in their cells. Okay? And then we narrow it down even more. So we're looking at living organisms that have a nucleus that are multicellular. So all the unicellular organisms that have nuclei and are living are not going to be included. So we're making the group smaller and smaller. And then we go down, and of the multicellular organisms, we have fungi, plant, and animals. And if we're just going to be looking at animals, and that cancels out, that narrows down plants and fungi. So now we're looking at only organisms that are classified as animals. And the group gets smaller and smaller the farther we go down here. Okay? So now we have our invertebrates, and they're all in their own little groups right here. So they're similar in the fact that they're invertebrates, but they'll have different characteristics in each of the groups. And we've already talked about those in our invertebrate unit. Um, and then we talk about our chordates, which are not invertebrates. Remember, chordates, they have that notochord at a point in their development. And they will also be in their own group. Here's the vertebrates category, okay? And each one of those categories will be smaller because those groups have similar characteristics compared to other groups. And yeah, so this slide doesn't really have a problem, but it's really good to sort of examine this diagram and just see how you can sort of use these options to narrow down which group an animal belongs to. All right, let's go ahead and listen to this next section right now.
In the past, animals were first categorized based on whether or not they had a backbone. A vertebrate is an animal that has a backbone. An invertebrate is an animal that does not have a backbone. However, as biologists learned more about the animal kingdom, the classifications of invertebrates and vertebrates were not enough. So the classification system was changed. Notice how most of the phyla are still considered invertebrates. However, phylum Chordata was updated to include animals called chordates, which are not invertebrates or vertebrates. True vertebrates are the animals most people are familiar with: mammals, birds, reptiles, fish, and amphibians.
Okay, so there were some interesting words used that I haven't really used in class before. Um, the first one is phyla. Well, phyla and phylum. Um, these are groups, classification groups that look at body shape, body type, body structure. Um, so the main differences are animals that have a backbone, they have that body structure, and animals that do not. That was the first form of classification. So we see right here that the early classification groups are included on this chart, the invertebrates and the vertebrates. But we also have animals that are not invertebrates or vertebrates. And I think this unit might explore some of those other chordates. So it's possible to be a chordate but not be a vertebrate or an invertebrate. There are certain species that start off parts of their lives with with a notochord, which makes them a chordate. But over their development, they lose that notochord and they become their adult form is not an invertebrate or a vertebrate. Oh gosh, I had an example for that. It's a type of early animal. We see this a lot in ancient in some fossils. We see fossils of larvae of sponge-like organisms that have notochords in them, but they lose them when they become adults. I gotta find out the name of that. Anyways, uh, so we're gonna go ahead and move on, but remember that phylum and phyla are just groups that sort of distinguish different body structures. So we've gone over the body structures of worms, echinoderms, cnidarians, mollusks, and we know their basic body plans. Okay, and the same thing with vertebrates. Although vertebrates, these ones right here are not phyla. The phylum that all these vertebrates here belong to is Chordata, because they are chordates technically. Okay, moving on. All right. Again, this kind of covers body structure. Uh, One of the earliest ways we categorize things is based on body structure. So remember the types of symmetry that we went over in class. We talked about things like bilateral symmetry, radial symmetry, and asymmetry. So those are just basic body plans. But you'll notice that all of these organisms right here, um, they have bilateral symmetry. So if I just drew a line straight through this turtle, on both ends it would look similar. All right, most animals have bilateral symmetry. Okay, so let's take a look at turtles, lizards, and alligators. What do they have in common? Well, we all know that they're reptiles. We've already done this section in class. They have dry, scaly skin. They breathe through their lungs. They have a 3 or 4 chambered heart, and their limbs usually have 5 clawed fingers or toes. Um, if you guys are in the chat right now, pull out the chat and go ahead and write another organism in the chat that has one of these characteristics, okay? That may not necessarily be a reptile. So I'll go ahead and write one right here. I'll go in the chat and type out my own comparison. And I'll say, hmm, let's do mice. Mice breathe through their lungs, okay? But they do not have dry, scaly skin. I don't think they have a three. I'm pretty sure they have a 3 or 4 chambered heart. They do have 5 clawed fingers and toes, though. So I'll go ahead and include that right here. They also have 5 clawed fingers and toes. So that's how they're similar to reptiles, but they don't share all these characteristics. So that's why a mouse would not be considered part of this group, despite sharing some things in common. So go ahead and if you guys are able to chat, go ahead and write an organism and whatever characteristics that organism shares in common that are on this list, go ahead and include them. I'll give you guys a couple minutes. All right, no one's responding. That's all right. If you guys are listening and it's easier to just relax and listen, I'm okay with that too. Again, this is being recorded, so you guys can always look back if you're joining late. Let's move on. Okay. Let's go ahead and have a listen right here.
Although vertebrate and invertebrate are no longer part of the official classification system, scientists still use body structures, like the backbone, to help them understand how to classify animals. The animals that most people recognize can easily be sorted. based on whether or not they have a backbone.
Oh my God, my microphone was muted. Good morning, Jetson. Uh, so yeah, as I was saying, we've already talked about invertebrates, and some of the groups that we discussed are right here. Sponges, worms, etc. Um, we haven't really talked about just where vertebrates fit into the entire animal kingdom. And we are in the minority, in fact. Only 3% of the classified species are vertebrates. So, um, just an interesting fact for you guys. All vertebrates have skeletons that help them move and protect their soft parts. Although we have differences in shapes, for example, this bat has a very different body shape than a chimpanzee. Uh, they all have skeletons in the long run. And we have our phylum, finally. Our phylum that humans and bats and lizards and apes all belong to is phylum Chordata, right here. Chordata. And of these 5 groups of chordates, we've already discussed fish, amphibians, reptiles. So we're moving on to mammals and birds. All right, we got to complete this Venn diagram. So first off, we got to we have 3 categories. We have a category for vertebrates, a category for invertebrates, and then a category for both. Now, you can't hear me? Jetson, can you hear me now? Can you hear me now? Am I hearable right now? Jetson, is that? Let me see. Yeah, my microphone should be working right now. Maybe I can lower it. Might be a little bit too loud. All right. Okay, that should do it. Okay, Jetson, where should I put the animals term? Should I put it in vertebrates? Should I put it in invertebrates, or should I put it in both? What do you think? Go ahead. I'm gonna go ahead and put this in the both vertebrates. I don't think so. It won't let me drag it there. Let me ask you a question. Is an earthworm, is that a vertebrate or an invertebrate? Ask yourself this question. Does it have a backbone? Well, actually, it does not have a backbone. It is an invertebrate, but is a worm also an animal? Well, yes, it is. So it's going to be both right there. Uh, for backbone, I'm going to put this in vertebrates because a backbone is part of a skeleton, and all vertebrates have skeletons. There we go. Uh, let's do consumers. Consumers. So are vertebrates consumers? Are invertebrates consumers? Or are they both consumers, meaning they both eat things? Give you guys a few seconds. And if you guessed both, you would be correct. Okay. Uh, doesn't matter if you're a vertebrate or an invertebrate. You are going to consume things. You need to eat. So we've already done backbone here. Great job, Jetson. Oh, so let's go ahead and put no backbone in the invertebrates because obviously it's not going to be in both. It's going to be the opposite of vertebrates. Okay, sponges. Ooh, it's been a while since we talked about sponges. Are sponges a vertebrate, an invertebrate, or are they both invertebrate and invertebrate? Huh. The question you should ask yourselves are, do sponges have a backbone? Let me go ahead and pull up a picture of a sponge. Sea spongy. All right. Here is. Ooh, that's a beautiful sea sponge. Does this look like it has a backbone? I don't think so. I don't think this has a backbone. I don't think it has a skeleton at all. It just looks like a very pretty a piece of the reef. So it is going to be in invertebrates category. What about fish? Do fish have backbones? Well, in fact, they do. We already talked about that when we first discussed vertebrates, so they will belong there. And both vertebrates and invertebrates need to reproduce. How are they going to make more of themselves if they can't reproduce? So both groups reproduce. Okay. We are going to move on. Absolutely right, Jetson. Great job. I really appreciate your participation. That's awesome. Let's move on. Okay. And here's just a little bit of text for us to read after we complete the activity. So again, I'll just go down here. Just because we might look very different from other types of animals does not mean that we do not share characteristics. We still have similarities with other organisms. Sometimes we have a lot of similarities, sometimes we have very few. But the fact that every single organism in the animal kingdom is classified as an animal tells you that you have a relationship to these creatures, um, as small as it may be. Okay, so now we're moving on to DNA classification. So when classification systems were first developed, they were first off really complex. They had really long names. No one could agree what to call certain organisms, but eventually that was figured out. And then there was a better organization to the classification of living things. But what might appear to just a regular observer that two organisms are, well, let me try to step back a bit and explain that again. So when early classification systems were developed, they only looked at the appearance of organisms. Okay, they only looked at their traits, the features that can be observed. Okay. For instance, you might look at a hyena. Let's take a look at a hyena, or let's do a spotted hyena. I like those. A spotted hyena. Let's take a look at this. What's a good image? Let's look at this one. So here's a spotted hyena. Oh, nope, that's not the one I want to use. Okay. That was an organ system we're not going to be covering just yet. So I'll take a look at this one. Yeah. So there's that, and then we'll take a look at an African painted dog. Let's see. Oh, that's really small. Let's look up a bigger photo. Oh, that's a good one. Okay. So we take a look at these two species, and we notice they look very similar. Okay. They both have. Well, let me try to go ahead and make this one separate. Nah, we'll just have to look at them kind of individually. All right, so here we have our African painted dog, and it's got this kind of rust color. It's got some white splotches. It's got these big ears. It's got a long snout, dark nose, long legs. And we take a look at a spotted hyena, and it's got the same rust color, got the same kind of ears, long snout, and you might think that, oh, these two animals are pretty closely related. They look so similar. But if you were to look at their DNA, you would actually discover that they're both very different. They're both not even technically, they don't even belong to the dog family, technically. I don't even think the painted dog belongs to the dog family, or the Canis genus. They have different classifications because their DNA is so different, despite looking very similar. So that's sort of the state of classification right now. Most classification looks at DNA, the genes of an organism, and sees how similar they are to the genes of another to determine how closely related they are. Remember that the whole classification system is based on grouping animals together that are similar or closely related, and DNA is the best way to determine how closely related an organism is. Um, and just to briefly talk about DNA really quickly, DNA is a type of molecule that's found in all cells of living things, and in DNA are the instructions that basically tell the cell what to do, how to specialize, how to act, or how to develop in a way that becomes that organism. So the DNA of these blue-footed boobies uh, contain all the instructions that allow a blue-footed booby to be a blue-footed booby. It's basically like a blueprint for that organism. If you guys remember Jurassic Park, if you ever seen that movie, they constructed dinosaurs by taking their DNA from fossilized mosquitoes. The fossilized mosquitoes had blood inside them, and they took the blood and were able to get the DNA, and then put it inside an egg and let the egg grow into a dinosaur. So they were taking the blueprint out of the blood from the mosquito and using that to create an organism. Now, it doesn't necessarily work that way. It's a lot more complicated than the way they did it in Jurassic Park, but it shows you that with the DNA, you have all the instructions necessary needed to create an organism. Okay. All right. So again, right here, this paragraph states that classification was based on how similarly organisms looked, and we were given these four different bees right here, uh, and they look very similar. They're both kind of yellow and black. They all have 6 legs. They have wings. They have mandibles. They have stingers. But some of them looked so similar that they were classified as the same species. But when scientists were finally able to research their DNA and take a look at it and compare it, they noticed that there were actually far more individual species than they had originally classified. So that is the value of DNA testing. It really shows you what the outside traits cannot. Okay, it's how we're able to determine our relationship with some very strange organisms, uh, and we'll discuss that later. It's actually really crazy to think that we share some characteristics with very interesting creatures. Okay, let's move on. Ooh, so we have an example of metamorphosis. Metamorphosis, okay? We have this is an example of complete metamorphosis because we have eggs that hatch into a larva that become a pupa, and then after the pupa stage, the adult emerges fully developed. I'm gonna skip this because we've already talked about this. All right, true or false? Let's go ahead and do these together. Hi, Crystal. How are you doing? True or false? There are more than 7 million animal species. Go ahead in the chat. Tell me if I should click true or false. More than 7 million animal species. Okay, if you wanted me to hit true, then you would be correct. It is true. There are more than 7 million animal species. Um, let's go on to the next one. All animals on our planet have been discovered. Is this true or false? True or false? All animals on our planet have been discovered. It is actually false. False. We've only discovered about 900,000 species, Crystal. If you're arriving just now, you must have missed when we talked about that, but that's okay. Again, I'm going to have a recording posted on the Google Classroom page, so if you did miss it, you can come back and get all the information. Um, let's go to the next one. Examining an animal's diet can help with classification. So looking at what they eat can help with classification. Does this help with classification? So do we group animals based on what they eat? So if I eat a banana and I notice there's a mold growing on my banana and it's also eating the banana, that means that me and the mold are in the same group? This probably is a false, right? We do not group animals based on what they eat because a lot of we actually eat a lot of the same things as some very very different organisms do. Classification of animals is nearly impossible. Is it impossible? Is it impossible? Mm, I would say no. I would say with the development of new technologies and the ability to examine DNA, classification of animals is very accurate now due to those technologies. So, wait, what? Oh, whoops! I meant to hit false. Sorry, I didn't mean to true. No, classification of animals is very, 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 very possible. Nope, that was a mistake. It's okay. Mr. Holden makes mistakes too. All right. Looking at an animal's DNA can help with classification. Well, that is true. We just talked about that. The similarities in the genes or in the instructions for that organism can show you whether you are closely related to another organism or not really closely related to. All right. And I think we're going to end it right here. Again, there's more to this lesson that you'll have to kind of go and do on your own. But you'll see that some of the some of the pages, you just have to read what's on the page, and you have the voice assist, audio assist if you need it. And then some pages you'll have to answer some questions. Okay. It's okay if you get them wrong. You don't need to worry. I'm just going to make sure that you guys are, kind of progressing where you should be and getting it done by the due date. I'm not going to assign anything else. Again, I just want you guys to finish Animals Part 1. But, well, actually, I will assign. Right now, I will assign a new assignment, but I don't want you guys to start it just yet. So after class, I will post an assignment to a link to Animals Part 2. It'll show up right here in your assignments tab. It'll say Animals Lesson Part 2. So I'll do that, but you don't have to start that until you're done with the Animals Part 1. So again, if you missed the start of the lesson, I kind of spoke about how to log in and where to go to start the lesson. If you missed it, again, check the recording. But for now, I'm going to take attendance. I'm going to take attendance. I bet you guys didn't think I was going to do that, but I am doing it. So in order to do your attendance, here's what I'm going to have you guys do. Okay, so I'll pull up my Google Classroom page. That's okay, Jake, if you can't chat or speak on live stream, don't worry about it. It's all right. So here's what we're going to do. Uh, in order to track attendance, it's kind of difficult because you guys have emails that may not necessarily be your name, or some other thing just prevents me from looking at your attendance. Like for instance, I can't see all the participants right now in the stream. I only see that 6 people are watching. So in order for you guys to get credit for being at this meeting, we're all going to use a keyword, okay? So here's what I want this to look like. I will share with you a keyword in the stream. I'll say something like potato, and you'll go on to the class page, and you'll make an announcement. So let me actually cancel this. You'll go ahead and post right here. You'll just say potato. and then your name. And that way I know that you were listening to the stream and you got the keyword and you were here, at least from at the end of the meeting. Maybe you missed the beginning, but the recording's going to be here either way. So go ahead and we'll make our keyword for this meeting SpongeBob. We'll do SpongeBob. SpongeBob is going to be our keyword, so I'm going to post this. And right underneath, you guys can make your own post, but it's easier if you comment on this one. Just write the keyword SpongeBob and then your name if you were here. And that way I can mark that you were present at the end of the meeting. So go ahead and do that right now. Just type SpongeBob and then your name, and I'll mark you as present. Okay? And that should about do it. If there are any other questions, let me check the chat. Okay. If you were here but you're unable to type on the classroom page, just send me an email so I can mark you as as having attended. And that should about do it. So I'm going to start uploading this recording right now, and we will have another meeting on Wednesday, and we'll go over some stuff, and yeah, should be good. Thanks for coming, guys. Take care, and you know, get your work done.
to the register and start all over from the canister. Let's break it all down into pieces of bright moments that pass by like a meteorite. Throw on your favorite jacket and you're good to roll on the analog trail and you look the roll. Just stroll through the trees and let your miseries go. Sunshine, hurricane, all the highs and lows. Yeah, we can take it all back to the register.
Good morning, good morning, good morning, good morning. Hello. How you guys doing? Let me see if I can pull up the chat right here. Hello, Nathan. Hello, Vika. Hello, Annalise. How you guys doing? Ooh, let's get started. Ba, 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 ba. Okay, guys. Let's listen to the song a little bit. Let's just get us pumped up for math. Everybody, everybody, start record right now. Alrighty. Hello, everybody. So good to have you guys back. Let me just arrange some things, make sure the chat's already there. I did not get more coffee. I ended up getting some tea, some apple cinnamon tea. I think it was a good choice. It's very, very smooth, very, very, very nice. Um, Ooh, that hits the spot. Okay, so you guys can see that right now I am on MobiMax. We are just going to quickly review the displaying numerical data section. You guys were also assigned something else, which I'll also show you. So let's just do a recap of logging into MobiMax. So on the sign-in page, make sure it's as a student. If it asks you to find the school, we just type Village Glen. Again, click Sherman Oaks, and we're good to go. So I'm going to log into my test account, and let's see what it looks like. Okay, so I have all these assignments here, but the main assignments that we're going to be doing, today we're going to review displaying numerical data. And then your new assignment is statistical questions, which it'll be due on Wednesday. It's a very easy lesson, so we'll go through both of them. But let's start with displaying numerical data right now. Click into it. Bada bing, bada boom. Oof, I love that math. Interpreting dot plots. Okay, so a dot plot is, well, let's take a look. We have a number line right here. This is the beginning of our dot plot. We need to actually have some kind of numbered line, and then we can begin plugging in our dots. So you can see that on this number line, every blue dot that appears over a value is a student based on the key. So we can see that this tracks the number of correct answers on Friday's quiz, and each dot represents how many questions were answered correctly. So this student, unfortunately, only got one correct. A couple students did really well and got 10 questions correct. Each column, by the way, we should note that the amount of dots in each column is the frequency. So over here, above 7, we see that there's 6 dots. So the frequency of 7 questions being answered correctly is 6. Okay. Uh, we're gonna keep moving on, and we can interpret a lot of things. We can answer different questions. For instance, the question that they gave us in the sample is how many students have 5 correct answers? Well, that was 4 because we have 4 dots here. So how many students got 9 correct answers? Well, we just take a look over here at 9, and we see 1, 2, 3 dots. So 3 students got 9 correct answers, and there it is. Let's see if they give us any more examples. A dot plot can also help us identify groups in the data. For example, let's see the example. How many students had at least 9 correct answers? So at least 9, meaning it could be 9 or more. So 9 and above, we got to count the number of students here. So we see that we have 3 students that got 9 correct and 2 that got 10 correct. So it's 3 plus 2, which should equal 5. All right. If we count all the dots, we will find the total number of students who took the quiz. Easy peasy. There's 30 students. There's 30 dots on this dot plot, so that's how many students took the quiz. Let's see what else. Let's see what else they give us. Oh, maybe not. I think that's it. I think we're paused. Okay, we'll move on to the next one. Dot plot shows data over a number line or a line of categories. It doesn't have to be numbers. The example they gave us with the quiz scores, that uses numbers. It uses a number line, but we can also use dot plots for categories like different colors here. So this particular dot plot shows the favorite color of students in a second grade class. And each dot obviously is colored, but each dot also represents a student. So we see that one student has red as their favorite color. That's the lowest frequency. And one, two, three, four, five, six students have yellow as their favorite color. That's interesting. Um, so if I wanted to ask you how many students like red or have red or yellow as their favorite color, well, we can just simply add them up. There's one person that likes red, and there's 6 students that like yellow. So 1 plus 6 is going to give us 7 students who like red and yellow. Okay, so we're going to answer this question here, and we're going to have to check everything that is true. A dot plot shows data over, well, it shows data over a number line or over categories. What we can see, those are our 2 examples. So we're going to put right here, we have a number line right here. And we also have a line of categories. Bins of numbers and Cartesian grids, those were not mentioned at all. So the 2 dot plots we're aware of are the ones that appear over, oh, let me just, oops, this looks bad. The only dot plots we see are the ones that have a number line right here, or they have a line of categories. Okay, so those are the 2 correct answers: number line, line of categories. Okay, dots show the frequency of the data. So we're going to take a look at this dot plot, and we want to know the frequency of the students that had 5 correct answers. Well, we just simply count the number of dots above 5 correct answers on the number line. So we see 1, 2, 3, 4 students had 5 correct answers, and that would be our frequency. So whenever I'm asking for frequency, let's say I'm asking for the frequency of students who got 8 questions correct, right? Well, the frequency is simply the number of dots above that particular category or value. Okay, so how many dots are there above 8? Well, there's 1, 2, 3, 4. So the frequency of 8 correct answers is also 4. Okay, so let's answer the question. How many students had 5 right answers? Well, that would be 4. Calculated that already. And we're moving on. Let's see. So, how many students are included in the dot plot? Well, if we remember, we counted earlier, or the program counted for us and told us there were 30 students on this dot plot. So, of if we're asking how many students took this quiz, well, every single dot that appears on this number line is a student who took the quiz. And since there are 30 students, or 30 dots on the number line, there are 30 students. So our correct answer is 30. Aw, Annalise. It's okay, we'll be back. Alright, add the 4 data points below the dot plot by dragging additional dots to the correct location. So let's see. We have 4 students, and I'm guessing we're supposed to put a dot for each of these students, okay? But before we do that, let's take a look at the number line right now. So the number line is between 0 and 8, and it is representing the number of books that each student read. Okay? So we're going to have to add dots for the 4 students here in the box. Now, let's start with the first one. Jamie read 5 books. He read 5. So we're going to look at for 5 on the number line. This is the number of books read. or this is shows how many students read 5 books. Jamie's dot is not here. Okay, so we're gonna have to add his dot in right now. Let's undo this, and we'll put a dot here for Jamie. So Jamie is good to go. We'll cross Jamie out. Bye bye. The next one is Cameron. Cameron read 6 books. Okay, so we're gonna go to the 6 book part of the number line, which is right here, and we're gonna add another dot. Let's go ahead and add the dot here for Cameron, and we can cross his name out. Now the next one, Kobe. Kobe read 3 books, so he's gonna have another data point above 3. So we'll go ahead and add it right here. Go back to the scratch pad, undo that, cross him off, and finally, Rakisha read 5 books. So we need another dot over 5, right? Read 5 books. Here is 5 on the number line. We'll go ahead and add that in right now for her. And this should be correct. This is all of the information. Perfect. Next one, add 4 data points. So it's the same kind of problem. We have to drag the additional dots to the correct locations. Okay, so we'll do this really quickly. Alicia read 1 book. Here is 1 on the number line, so we'll add a dot over there. Carla read 2 books. The 2 on the number line is right here, so we're going to have to add another dot over here. Bo read 8 books. Wow. Wow, fast reader, Bo. So we'll look at 8 on the number line and add a dot over there. And Alan read 3 books. So we'll put a dot over 3 for Alan. And there we go. Easy peasy. And this tea is good too. All right. Use the dot plot to match the correct number with each value below. Alrighty. So let's take a look at all these. And the number of students that read 4 books. 4 books. So let's take a look at 4 on the number line here. We have 4. That's where that's the number. So sorry, this is where we're going to track the students who read 4 books. So let's take a look at the dots or the frequency right here. So the frequency of students who read 4 books is 1, 2, 3, 4, 5, 6. Okay. Now over here on the problem, it says that 0 students read 4 books. Well, that's not correct. We know it's supposed to be 6. And I have a 6 right here, so I'm going to drag it over and match it up. Right. Number of students that read 1 or 2 books. So we're going to be looking at 2 data points now. 2 data points. We have to look at the number that read 2 books and the number that read 1 book. Well, the number of students that read 1 book is only 1. And the number of students that read 2 books is 1, 2, 3, 4. So in total, we got to add them together. And we get 5 students that read either 1 or 2 books. Okay? So let's take a look. We have a 5 right here. We'll swing that over and match it up with this particular statement. And now we're going to look at the next one. The number of students that read 5 books. It says 23, but if we look on the number line, we see that 0 students read 5 books. Wow, 5 must be an unlucky number. So we have to go ahead and replace this 23 with the 0 here. And by process of elimination, it tells us that the total number of students who read books was 23. So we'll just go ahead and tally these up. Let me go ahead and get rid of this, and we'll count them up just to make sure. So 1, that's how many people are in this category, or that's how many students read 1 book. 4 students read 2 books. 3 students read 3 books. Oops. 1, 2, 3, 4, 5, 6 read 4 books. 0 read 5 books. 1 read 6 books. 1, 2, 3, 4, 5 read 7 books. And 1, 2, 3 read 8 books. So if we add these all together, 1 plus 4 is 5. Plus 3 is 8. Plus 6 is 14. Plus 0 is still 14. Plus 1 is 15. Plus 5 is 20. Plus 3 is 23. So yeah, it all checks out. So we can move on to the next one. Alrighty. don't share phone numbers in my chat, please. That's not a good idea. Everyone who's here can see it. That will be very, very bad if you gave out your number to the entire class. Okay, so let's go ahead and do this one really quickly. So the number of students that read 3 books, I'll go with my scratch pad here. 3 students read 3 books. So we had to take this 3 here, match it up. I guess that gave us the answer for this one as well. So let's just double check this right here, because it said this statement was correct as well. So the number that read 6 or more books. So for 6 or more books, that means if they read 6 or 7 or 8. Okay? So we gotta add these all up and make sure it adds up to 13. 1, 2, 3, 4, 5 students read 6 books. 1, 2, 3, 4, 5, 6, 7 read 7 books, and 1 student read 8 books. 5 plus 7 is 12, plus another 1 is 13. Ooh. That actually looks really bad. So over here, 5 plus 7 plus 1 will equal 13. So yeah, this statement is true. Whoops, that looked really bad. This statement is true. We just double checked it. Alrighty. Let's delete everything. Alright, number of students that read 2 books. Alright, let's take a look. So only 1 student read 2 books. So we'll go ahead and switch this 1 here. And looks like we're correct. And this last statement, the number that read 4 or fewer books. So 4 or fewer means that we're going to count the students that added that read 4 books or any books less than 4. Okay, so 4 or fewer. So we have 2 that read 4 books. We have 3 that read 3 books. We have 1 that read 2 books. No one read 1 book. And we have 1 student who didn't read a book at all. So we add these all up together. 1 plus 0 is 1. Plus 1 is 2. Plus 3 is 5. Plus 2 is 7. So it matches up with the 7 next to this statement. Alright. So far so good. Okay, now we're going to get into some practice here. I'm not sure if you guys get the same questions, but let's just answer these together. How many students are in the 2nd grade class? So if we look at the title, this dot plot shows the favorite color of students in a 2nd grade class. So if we're wanting to know how many students are in the 2nd grade class, we'll have to count up all the dots that appear on this dot plot. So let's go ahead and count them up. We have 1 student that likes red, 3 students that like green, 4 students that like blue. I can't reach here, I'll write it down here. 1, 2, 3, 4, 5, 6 students that like yellow, and 3 students that like orange. So I'm going to have to add up all these numbers. Let's do it down here. 1 plus 3 plus 4 plus 6 plus 3. Make sure I'm not missing anything. Looks like I have everything. So 1 plus 3 is 4. Okay. 4 plus 4 is 8. 8 plus 6 is 14. And 14 plus 3 is 17. So there should be 17 students in this 2nd grade class. And we got it. Perfect. What is the least favorite color? Okay, well, the way this question is worded, it wants us to to answer with the color that was picked the least, or the fewest number of times. So we can see that red is the lowest, the least picked favorite color. So we would go ahead and click red. And the reason we know it's the least picked is because there's only 1 dot above red. That means only 1 student likes red more than the other colors. Alright? Perfect. Question, how many more students like blue than orange? Okay, we're getting a little bit trickier of a problem. So we're comparing blue and orange. And the question wants to tell us how many more students like blue than orange. So let's go ahead and take a look. There are 4 students who like the color blue. And there are 3 students, that was a really big circle. There are 3 students that like the color orange. So we want to find how many more is 4 compared to 3. Well, the easiest way to do that is simply subtract. So we're going to take 4, I'm going to subtract 3, and we get 1. So 1 more student likes blue than orange. And if we take a look, that makes sense. 4 students is 1 more student than 3 students. Alrighty, back to the original dot plot. How many students answered 7 questions correctly? Well, this is just asking for frequency. So we need to take a look at the number of students who got 7 correct, and we see 1, 2, 3, 4, 5, 6. Our frequency for 7 questions being answered correctly is 6 students. How many students got 6 right answers? Well, again, it's another frequency question. We'll take a look at 6 on the number line. And we see that 1, 2, 3, 4, 5 students got 6 right answers. And now, I'm making sure I'm reading the question correctly. It asks how many students got 6 right answers. It did not ask how many students got at least 6 right answers. If the question said got at least 6 right answers, then I would be looking at not only the number of students who got 6 correct, but 7, 8, 9, and 10 as well. Okay, so make sure we're reading the questions carefully. Let's move on, and that one's correct. Alrighty, so I believe this is the first lesson. We're going to start talking about histograms now too. It's another another way to display numerical data. So let's take a look right now. Woof! Look at this chart. Let me try to zoom in here. This chart shows the number of students who became sick with the flu after the first outbreak. Huh. That kind of seems a little familiar. This chart now shows the flu cases summarized every 7 days. Okay, so we see that they divided up the new cases every 7 days. So this chart tracks every single day. This one tracks every 7 days. Okay, and we see the frequency is the number of students that became sick with the flu between those days. Is that it? Are they gonna ask us more questions? Okay, they don't. So here is a histogram, and a histogram. If you'll excuse me, hold on a second. Ooh, actually, be right back. 10 seconds. Okay, maybe not 10 seconds. I just had to get a napkin. Alrighty. So a histogram uses bars of different heights. It's like a bar graph in the sense that well, we're using bars, but typically we are using numerical or categorical data. Um, uh, let's go ahead and get right into the lesson. Actually, well, no, we'll take a look at this graph first. Um, so, again, each of these bars represents a section or a category of days. So the first bar right here represents days 1 through 7, and we could see that the x-axis or the horizontal left and right axis is broken up so that it marks every 7 days. Okay. Let's go ahead and move on. So the whole point of a histogram is to put everything into equal groups. So in the case of the histogram that we saw on the last page, the equal groups are just every 7 days. Every group is just 7 days. Okay, so that's how we distribute the histogram into equal groups. Now, the numbers we get aren't going to be equal, but at least we know that every category is going to be an equal segment. Okay? So let's go ahead and describe a pattern to this data. This is going to be interesting. Okay? There was no real pattern in the number of flu cases. No, there is a pattern. We saw that it grew over time, and it got worse and worse, then eventually subsided. The average number of flu cases was 35 per day. Well, let's take a look at that. So if we want to find the average, we're going to have to add up all of the incidences of people getting sick and divide it by the number of times we add it up. So we're just looking for the average here. So let's go ahead and do it. I'll go ahead and circle right here. Here are our numbers. We're going to add these all up to get the sum. And then once we add them all up, we'll divide it by however many numbers we added together. So let's just count this really quickly. I have 1, 2, 3, 4, 5. 5 numbers that I'm adding up together. So I'll just go ahead and remember. I'll just put a little 5 up here. Oh, I can't. Won't let me. That's not a good place to put it. I'll put it right here. We're adding up 5 numbers. Okay? So when we finally add them together and get our sum, we'll be dividing by 5 after. So 11 plus 23 is going to be 34. Plus 44 will be 78. Okay, I'm going to need a calculator for this. Can't do this all in my head that fast. Let's see. 11 plus 23 plus 44 plus 35 plus 14 equals 127. We'll divide this by 5. Ooh. That gives us 25.4. Now, that's the number of cases every single day. Or sorry, every 7 days. So every 7 days there was about 25.4 cases. Let's say we want to determine what the incidence was every single day. We'll have to go back to our original number, 127. And we're going to have to divide this by the total number of days, okay? So what we can do is instead of dividing it by 5, which will tell us every 7 days, we're going to divide actually by 1, 2, 3, 4, 5, 35. Let's go ahead and divide by 35. 127 divided by 35. About, okay, so it gives us a really ugly number here. But if we round it down, we get 3.6 cases per day. Okay? So it took a lot of work, but we know that the average number of flu cases was 5 per day is not correct. It's a little bit less than that. Let's go to the next one. The highest number of flu cases occurred at the end of the period measured. Well, let's take a look. The end of the period measured would be just the final entry in this chart, and we see that after the last 7-day segment, 14 people got sick. But this isn't the highest number of people that got sick. The highest number of people that got sick was between day 14 and day 21. That was a total of 44 people. So let me just mark it. Try to delete everything here. There we go. So we see that 44 people got sick in this entire week, okay, which is the highest number. So the highest number is not the final or the end of our measured period. So this is not true as well. Let's take a look. The number of flu cases rose until the 3rd week and then declined. Well, let's go ahead and take a look at each week. So we're going to break this up into weeks. Every 7 days. And luckily they marked every 7 days with the number of cases per week. So we'll go ahead and take a look at the first week. This is week 1. And then we'll take a look at the second week. This is week 2. And then the third week would be week 3. And this is week 4. And finally, we end up with week 5. So I'm going to close this out really quickly and take a look at that statement again. The number of flu cases rose until the third week and then declined. Well, let's take a look. Oops. It mismatched everything. Alright, let me see if I can do this one more time. Nope. Match up correctly. No. How about this one? There we go. Okay, now it's matched up. So in week 1, there were 11 new cases. Okay, that's what we started. In week 2, there was 23 new cases at the end of week 2. And then at the end of week 3, there was 44. At the end of week 4, there was 35. Okay, so what do we notice? We notice that the number of new cases every single week got higher until the third week, and then it dropped from 44 to 35. So that statement is actually true. The number of flu cases rose until the third week, and then they started going down. The average number of flu cases was 6 per day. Again, I don't believe that was true. We calculated something different, so let's keep going. All right, perfect. We got it right. There was only one correct statement. And it took us a lot of work to find out which one was correct, but we did it, and it's possible to do it. All right, let's take a look at this histogram. Actually, let me check my stream, see if anyone's asking questions. Here we go. No one right now has any questions. That's perfect. You guys are all seeing everything okay and hearing me okay? Just let me know if there's any problems or you want me to go over something again, and we could definitely do that. All right. Let's go ahead and do a couple more questions for histograms, and then we'll go over to what was it? The box and whisker plots. Okay. How many students are between 45 and 49 inches tall? Well, unlike the dot plots, which had dots to show how many students fit into each category or each number, we're not given them. We're just given a sideways left and right number line and an up and down number line right here. So if you take a look at the left and right number line, these are just height categories. So we're taking, well, let's examine this really quickly. So we have a category for students who are between 40 and 44 inches. We have a category for students who are between 45 and 49 inches, 50 and 54, 55 and 59. So it's broken up into equal groups. So basically, if you're within this range of inches, you are placed into this group. It doesn't tell you exactly what height each student is, but it tells you which group they fall under. Okay. So, well, that's a tall sixth grader. That guy's probably 6 feet tall. Okay, height of each student in sixth grade class. Which height range is the least common? Well, we can see that there's only one student who fits into the 70 to 74 inch height range in this class. So this is the least common. It's going to be the lowest bar on this graph. We can use information in histograms to answer questions about our data. All right, well, we can look at, first off, the title of the graph. The title of the graph is height of students in a sixth grade class. So that tells us what we're measuring. We're measuring, just how tall they are. We're going to record how many fit into each height range. The tallest bar is the most common height range. So in this case, the tallest bar is between the 55 and 59 inch category. And there are 5 students who fall in this height range. And then the lowest bar, which we already talked about, is the least common height range. So whichever bar on your histogram is the lowest bar, that tells you the least common range for that particular set of data. So which height range is the least common among the sixth grade class? Well, that will be the lowest bar, and that is the 70 to 74 inches height range. Alrighty. I'm going to skip through this. I'm just going to skip through it really quickly. Oh gosh. I can't skip it. I have to go through this all together. We are running out of time, so I'm going to try to do this fast. Use the histogram to match the correct number with each value below. So number of students shorter than 5 feet. Here they give us a graph with decimals of different heights in feet, of course. So this is 4 to 4.4 feet, 4.4 to 4.8 feet, and so on and so forth. So students who are shorter than 5 feet, well, we have to look at these three categories. There is one student in the 4 to 4.4 foot range. There are 3 students in the 4.4 to 4.8 foot range, and there's one student in the 4.8 to 5 foot range. All right. So that would be 5 students total. Okay, number of students between 4.8 to 5 feet. There's only one student who is in between that height range, as we can see. Let me show you on the scratch pad. The reason there's one is because it matches up with the one right here on this on the up and down line. Okay, so one student falls within that category. Match it up. All right, number of students who are taller than 5.4 feet. Well, let's find 5.4 feet on the graph. 5 to 5.4 feet is right here. So we're looking at students who are taller than 5.4. So we're not going to count any of the 5 students in this bar because the range is between 5 and 5.4. We need to look at students who are taller than 5.4. So we're going to look at the next categories instead. And we're not going to count this one. So there are 4 students in the 5.4 to 5.8 range. And there is 2 students in the 5.8 to 6 foot range. So we add 4 and 2 together and we get 6. And by process of elimination, we find that there are 16 students who were measured and put into this histogram. Okay, another one. Let's take a look at this. So this graph measures the distance or how many students or what there's no title to this one. So this histogram looks at how many students how many students live within specific distances from school. So we're given our distance ranges 0 to 1 miles, 1 to 2 miles, 2 to 3, and so on and so forth. And we're given a number of students who fall into each distance range. So students who live within 1 mile of school, this would tell us that we're going to look at this between the 0 to 1 mile range. And there are 1, 2, 3, 4, 5, 6. We notice that the bar stops at 6. So 6 students live within 1 mile of school. Oh, and that gives us the correct answer for the last statement. Students, there are 3 students. We can see right here. The bar lines up with 3. There are 3 students who live between 1 and 2 miles away. So this statement's correct. Student homes between 2 and 4 miles away. Well, let's take a look. So we don't have a 2 to 4 range. We have 2 to 3 and 3 to 4. So if we looked at the values of each, okay, I don't know if you guys can see that well. But this is the 2 to 3 mile range. This is the 3 to 4 mile range. So all of the students who are in these 2 bars would be between 2 and 4 miles. Okay? So there are 3 students. Let's mark this. There are 3 students who live between 2 and 3 miles away because we can see that our bar lines up with 3. And there are 4 students who live between 3 and 4 miles away. So we're going to have to add these together. 3 plus 4 would give us 7. So 7 students live between 2 and 4 miles away. And the last statement that was already answered correctly was the students that live 4 or more miles away. Well, no one lives between 4 and 5 miles, so this would be 0. Let's cross this out. This would be 0 students that live in this range. But then 2 students live between the 5 and 6 mile range. And the statement wants us to put how many students live 4 miles or more. So between 5 and 6 miles is greater than 4 miles. So that's why we count those. All right.
quick question about this. This histogram shows the number of tickets sold during the day. What is being measured? Well, let's take a look. We can see that our up and down axis is recording the amount of tickets sold, and our left and right axis is recording the time that it was sold, or between the time range, I guess. So there were 100 tickets sold between 9 a.m. and 12 p.m. There were 250 tickets. This is between 200 and 300. So this is about 250. There are 250 who bought between 12 and 3 p.m. And we can just keep going and look at the data like that. So let's answer these questions. What is being measured? Well, the number of tickets sold during particular time periods, that's what we see on this graph. Each one of these bars is a time range. This bar is between 9 a.m. and 12 p.m. This bar is between 9 p.m. and 12 a.m. So we see the day is broken up into 3-hour segments, and we see which time period or which time range are the most tickets sold. Time of the day. I think we're going to leave it at that. Yeah, there we go. And these are just questions based on histograms. So I'm going to go through these really quickly. What time of the day do you need the most ticket takers? Do you need the most ticket takers? I guess the people who collect the tickets. You'll need it between 3 p.m. and 6 p.m. because we see a lot of people are buying tickets between 3 to 6 p.m. Which time of day do you need the least ticket takers? Well, the fewest tickets were purchased between 9 a.m. and 12 p.m. So you wouldn't need that many people working this ticket booth during that time. So 9 a.m. to 12 p.m. And not last but not least, how many tickets were sold from 12 p.m. to 3 p.m.? So from 12 p.m. to 3 p.m. there were about it looks like 250 because it's between 300 and 200, but the closest that we get is 240. So we're just going to have to approximate and say that this particular bar, I guess, is closest to 240. All right, it's right in the middle there. Perfect. Okay, if a ticket attendee can sell 20 tickets an hour, how many ticket attendants do you need from 12 p.m. to 3 p.m.? Oof, 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 oof. Okay, this is going to require us to do a little bit more division. Let's go ahead and do this right now. A ticket attendant can sell 20 tickets an hour. How many tickets do you need? So from 12 to 3 p.m., there are 240 tickets sold between 12 and 3 p.m. Okay? Now, let's go ahead and divide this by, should we divide this? Well, we'll divide it by 20, I guess, for starters. The number of tickets that can be sold in an hour. So let's go ahead and do that. 240 divided by 20. So remember, 20 is the number of tickets that can be sold by one attendant every hour. So if we divide the total number of tickets by 20, we'll see how many hours it'll take for one person to sell 240 tickets. Okay, so 240 divided by 20 is going to be 12. There we go. So it'll take 12 hours for one person to sell 240 tickets. But luckily, we can have more attendance to make sure that we're selling all these tickets. Okay, so 12 hours are needed. Let's go ahead and label this. There are 240 tickets. I'll just put TI for tickets, and 20 tickets per hour. Okay, that means it takes one person 12 hours to sell that many tickets. Now, we'll divide this by 3, okay? Because remember, we only have 3 hours. Between 12 p.m. and 3 p.m. is only 3 hours. So we'll divide 12 hours by 3 hours. And we'll get 4, okay? So the reason why we divided by 3 hours is because remember we only have a ticket attendant that can work every 3 hours. So we're gonna need 4 ticket attendants. I'll put TA right here. 4 ticket attendants to sell tickets between 12 and 3 p.m. It was a little bit tricky. There's probably an easier way to solve that. All right. Box and whisker plot. Do we have homework? What's homework for today? You know what? Let's take a step away from box and whisker plots, and we'll go ahead and talk about the homework. So let's go back here. If you guys have already done the entire lesson, then that's great. I simply went over some of the lessons so you guys can see it together. Ooh, let me go back. Under the assignments tab, you'll receive the assignment statistical questions. It was assigned today. This is the lesson that will be due this week. Okay? So it's only one section. Actually, I'm going to make this due Wednesday. You guys should be able to finish it in time. And we'll do a couple sample problems together, and then we'll close the stream from here so you guys can have your lunch. All right. So a statistical question involves more than one data point. Well, how do we know if a question involves more than one data point? Let's take a look. Which question below deals with more than one data point? So let's take a look at the incorrect answer first. So how old are you? If you were to answer this with your age, you're only giving one data point, and that data point will be the age that you are. Okay. So when you're responding, when you're looking at a question, if it only asks you for a specific thing, like the age or the length or some kind of measurement of one object, that is not a statistical question. It is a measurement question. Okay. So, but when we're asking a question that requires us to get multiple measurements or multiple numbers, multiple data points in order to answer it, then that is a statistical question. So if you ask what are the ages of all the students in the school, I'd have to ask every single student in school what age they are or find that information. And there's more than one student, so there's going to be more than one age that I'm going to record. So this is a statistical question. All right. Which of these is a statistical question? Well, how many points did each player on the team score? It looks like in this specific question, I have to look at every player's points. So that's more than one player, more than one point measurement. So this is a statistical question. As opposed to how many points did you score? There's only one answer to that. Okay. So this is not a statistical question. Okay. Which is a statistical question? Well, you know what? How about this? Which of these questions has more than one answer? Let's take a look at this one. What was your score on the last exam? That only has one answer to it. Okay? But the other question is, what were the scores of all the students in your class on the last exam? That's more than one answer. Students will have scored all over the place. So this is a statistical question because it has more than one answer. Okay? So moving on. And that's pretty much it. There's only 5 questions. There's a little bit of practice, but this is basically what you have to be doing. Just determining which of the questions that you're given are statistical questions, and that's your assignment for today. It should be pretty simple. All right, let me go ahead and just wrap up here. Oh, Nathaniel already finished it. Well, look at you. Good job. Let me have some tea really quickly. So I'm gonna pull over the Google Classroom page really quickly. Here is the Google Classroom page. If it's popping up on my stream. Okay, we're good to go. Let's quickly talk about how we're going to record attendance. So I can see that there are 7 people watching the stream right now, which is awesome. But I don't know who is who. I mean, if you guys typed in the chat, then I know that you were there. But let's say you were just listening and watching and weren't really typing. Well, how am I going to collect your attendance? That's pretty easy. On the classroom page, I'm going to make a post. I'll just call it attendance post. I'm going to post this right now. And you'll have to add a comment to that particular post. So I'm going to go ahead and add a comment here. And I will give you a keyword during our live sessions. So the keyword could be histogram. The keyword could be dot plot. We're going to go ahead and have the keyword be frequency this time. So in order to get credit for attending, on the attendance check post, you'll have to type the keyword. In this case, it's frequency. And then you'll type your name. So I'll type frequency and Anthony. And then I'll post that immediately. Once I know what the keyword is, I'm going to post it immediately so that I can receive credit for attending the class. So go ahead right now, and if you're here right now for this part of the stream, go onto the Google Classroom page, put a comment on this attendance check post with the keyword frequency and then your name, so that I know you were here from the start of the lesson, or at least you joined the lesson and stayed up until now. Okay, so that'll be it for our meeting today. If you guys have any other questions, feel free to leave a private comment, email me, well, that's the only really way you can get in touch with me. So please leave me an email or put a post on the Google Classroom page, and I can see what I can do to help out. All right. Any closing statements? That was your homework, Nathaniel, the statistical questions. It was really simple, I know, but I'm not going to assign anything else until Wednesday. So on Wednesday, I'll give you guys a new assignment on your Moby Max, and we should be good from there. Alrighty. Any last questions? I'll give it a few more minutes before I close the stream. That's fine. You can start the Moby Max in the afternoon. You don't have to do it immediately. Of course, Nathan, you're welcome to do it whenever you choose to, as long as it's due and done. As long as it's done by Wednesday, then you're good to go. Alrighty then. I'm gonna take off from here. Thank you guys so much for coming. I really miss you guys. I hope you're doing well. And looking forward to seeing you guys back when we get out of this closure. So take care, and see you on Wednesday.
Check it. Check it. Oh, I think I got the fever. I'm heated. Pumping up the meter. Roll me a ringleader, bad party bleeder. Make it with a storm. Lead after lead after leader. Hey, can you dig it? I come alive, only give me what you got. Back up, pump, shake up, pump your fist up. You check the shadow, no buckshots, a bus slip up.
1, 2, 3, and 4. Count what you have now. Don't count what you don't have. Count what you have now. Don't count what you don't have. Find that you have so much.
Okie dokie. I see that we got some people on the stream right now. I'm still assembling a few things. Um, Making sure they're ready for our lessons. So hang in there. We'll try to start in about 5 minutes, give or take. Again, I'll try to make sure I'm on time in the future, so that everything you guys are ready to go and we can get through with everything and you guys don't have to wait. So I apologize. Uh, Next meetings will hopefully start right on time, or they will start right on time. I'll make sure I take the extra time in advance to arrange and get everything ready. Okay, 5 minutes. Alrighty. Alrighty. Okie dokie. We are live. Oh, that's my timer. Good thing I set the timer. Okay. I'm gonna try to get things ready. First, I gotta turn this off. And, turn the stream on, and we should be good to go. Hold on a second. Turn off this. Turn on this. Okay. Alrighty. So, welcome everybody. Let me pull up the stream and the chat right here. So if you guys are turned, let me see. Ooh, you guys are already talking. Am I in the right place? Yes, you're in the right place, Matthew. Aaron, you're in the right place. The correct place. I guess semantics is necessary. Okay. So, let's first go over a few things. Uh, I had some questions about science fair that a student sent me and asked on my stream, and they wanted to know what's going to happen with science fair. Oh, let me just go ahead and start recording. Let me start recording right now. All right, we are recording. So I had some students ask me, what's going to happen if science fair is canceled. What do we do? Well, we're still going to complete our projects because we've already started them. Some of you guys have already, put in the work and bought materials for your projects. So we're still going to do them. If there is no science fair, if we decide if it's canceled, then we will still complete the projects. We just won't do our boards. I still want to see you guys go through a process using scientific method to test different variables. So it's still going to have to be done regardless whether we do our science fair or not. Okay. So now that that's out of the way, let's talk about what we're doing today. If you notice, I just posted a new assignment in the classwork section. Let's go ahead and access it right now. So the assignment is just a way that I can tell that you guys are, following along with the lesson. There's three kind of key questions that correspond with the key questions in this section of our book. So after the end of the lesson, we'll try to keep it as short as possible to give you guys extra time to work on these. But by the end of the lesson, I want you guys to let me go to a student view. Okay. So I want you guys to respond to these questions by creating a Google Drive. You could also use Microsoft Word and just upload a file if you want to, but answering these three questions is how you'll obtain class credit for today and also attendance credit. But we will do an attendance check towards the end as well. Alrighty. Let's get down to business. So, first off, I want to talk about the materials and procedures list that I received so far. Let me go back here. I'll pull this whole thing over, and then I'll try to wait. Let me renegotiate this really quickly. Minimize this. Get rid of that. I'm gonna go over and pull up some. Yikes. Close windows. No, I want to keep this. All right, move this over here. I'm going to pull up some of the materials and procedures list that I've received so far, just so I can go over sort of what I'm looking for. To those of you who returned in a materials and procedure list, I appreciate it. Let's take a look at Matthew, since he's right here right now. Okay, so Matthew looks pretty good. Very simple materials and procedures list. Here's what I'm looking for. I'm looking for the materials to be listed out in bullet point. Now they're listed out neatly here with no bullets, so I guess this is fine. But if you list it out in bullet points, you might not have to go through the trouble of formatting it so that it looks really nicely. Second off, the procedure. The procedure needs to be numbered steps. So this needs to be changed so that there are numbered steps. And I can go through and show you an example of a really simple materials and procedures list. that follows this format, and that would be Mr. Moon's. Mr. Moon, your materials and procedures list looks really good. Very specific with what models of Nerf guns you need. The procedure is very simple. Uh, there are some details I would add, but again, you have the materials bulleted out. You have the procedure in numbered steps. I'm missing some detail though. Shoot the blaster across the chronograph 10 times. Is a little vague. Remember we talked about adding a diagram to sort of show visually what it would look like. And I know it's really hard to do that on a Word document, but some detail would be a little bit better here. You know, maybe put the distance that you would stand away from the chronograph. Uh, you'd have to um, you'd have to make sure that that was repeated each time, the same distance. And other than that, I mean, for step 4, I would say repeat steps 1 through 3 with different blasters, and then compare the results taken from your chronograph tests. Just a little more detail. I would appreciate that on your procedure. But overall, I mean, this is the format I'm looking for, so this is suitable. If you made some mistakes in formatting of your materials and procedure list, go ahead and go back, change it, and then resubmit it. I think you can still submit it after it's due. It'll appear as late, but right now I'm going to be a little lenient as there are still students trying to access the class and they're having trouble, getting on Google Classroom, or they have device issues or network issues. I'm gonna go ahead and accept anything you guys turn in late, or anything that you have to redo and resubmit. Don't worry about any penalties. I just want to make sure that we're all doing it the right way. All right, so let's close out of this, and let's go ahead and talk about 18.1, that worksheet that I was assigned in the very beginning of class. I will post the answers to 18.1 and 18.2 tomorrow on the page. I'll list it as a material. You guys can go in and double check your answers, make sure you got them right. Uh, if I do this and I post the correct answers, and then I receive submissions from students with literally the exact same answers that I put, then I will begin marking late credit. Okay. So I know that Garrett asked, or one student asked, if we can have correct answers posted. I will do that, but as soon as I post the correct answers and I receive submissions, every single submission after I post the correct answers will receive late credit. I don't want you guys getting full credit just copying the correct answers if you missed something, okay? So that'll be done tomorrow, meaning you have tonight to get everything in with no penalty. Um, and this is just talking about the worksheets. It's nothing to do with the material and procedure list. If you guys submit that late, I'm not going to penalize you. There's no there's no correct answers for that. But if you do need to reformat your list, please do that. Alrighty. So let's start talking about section 18.2, modern evolutionary classification. Let me see if I can. Oh, I guess I can't. How do I undo what I just did? I guess I can't. All right. So, we've already gone over 18.1, where he talked about just sort of the basic sort of taxonomic categories for the classification of life. But we use some very different methods today to classify animals, well, not just animals, but organisms in our modern time. And we've been able to kind of do so with using knowledge of DNA and genetics, and technology, which has allowed us to compare the DNA of different animals and really trace lineages and compare how closely or distantly related organisms are. Okay. Um, let's go ahead and let's talk about what is the goal of evolutionary classification. What's the point of looking at every single living thing that we can see and observe and putting it into a group, um, a group that demonstrates evolutionary relationships? Well, the answer is simply right here. The goal of evolutionary classification is to group species into larger categories that show lines of evolutionary descent rather than overall similarity and differences. So, the point of classification today is to trace the evolutionary relationships between organisms, not just to put organisms into categories where they have similar traits. Like, okay, we'll put all the reptiles in the reptile class Reptilia because they all have scales and they're all and ectothermic. Now we can go back and really trace specifically where different species sort of evolved from, and how they are, how closely they're related to others. Um, so that is the purpose of evolutionary classification. It takes into account more than just the traits that are similar between organisms. It takes into account its evolutionary history. Uh, there's a couple words that are going to be used to describe just overall groups in this section. The first one I highlighted right here. Um, when we're dealing with these relationships, evolutionary relationships, we put species into groups called taxons. But that's not the only word for group that we're going to be using here today. Okay, so a taxon is generally a large group. So if you were thinking, a large group would include all plants. You can have a taxon that includes all plants. And by the way, the plural for taxon is taxa, T-A-X-A. Taxon is just a singular group. So plants would be a taxon, animals would be a taxon, fungi would be a taxon. But as we narrow down what we're looking for and investigate smaller and smaller groups, we use a different term to describe them, and that term is clade. So right here, clade. A clade is just a group of species that includes a single common ancestor and every single one of its descendants. So let me go ahead and I'll pull up the clade that I found for humans. And this isn't a complete clade. Where is it? Right. So here we go. Here is a clade for humans. This diagram is what we call a cladogram, and I'll explain that soon. But here is our common primate ancestor, right? And a clade would include that ancestor and all of its descendants. Now you see how these lines kind of make their way and split up into different species. Well, all of these species uh, had this ancestor in common. Every single one of these species that we see today. So this is a clade. It's the ancestor in every single one of its descendants. So uh, we are the descendants of this primary ancestor, along with chimpanzees, gorillas, orangutans, gibbons, old and new world monkeys, tarsiers, and lemurs and lorises. So this would be a single clade, and it's monophyletic. What does monophyletic mean? Well, a monophyletic group includes a single common ancestor and all of its descendants. So it's the exact same definition as a clade. We just describe a clade as a monophyletic group. So one ancestor, all of its descendants. Let me go back here. So here's the one ancestor, whatever species that could have been, and there are also ancestors of this ancestor too, and we can examine other clades that include this ancestor as one of the descendants. But every single species on this cladogram is a descendant of this ancestor, so it's monophyletic as a result. Okay. Uh, so you got to remember that before we were able to trace these evolutionary relationships, Carolus Linnaeus, the guy who invented the Linnaean classification system, he put together groups based on the similarities that he observed between organisms. And what ended up happening is that he took similar looking organisms and grouped them together, but despite their similarities, they were not closely related at all, or they did not descend from the same ancestor. So they were not monophyletic. Um, these groups have common ancestors, but if we're talking about the groups that were miscategorized as monophyletic, some of the groups have common ancestors, but not all the descendants share that ancestor. So a good example of this is the reptile class, class Reptilia. It's not monophyletic. There are descendants that have different ancestors, but uh, due to the environment, due to the evolutionary pressure, they developed traits that are similar to reptiles, but they didn't get them from the same ancestor that reptiles did. I think a good example of this is probably the Tuatara, but I have to double check on that. So, reptiles is not a monophyletic group. There are members in, if we're looking at it in the old classification system, there are members of the reptile family, or sorry, the reptile class that did not descend from a common ancestor. Okay? Um, we still use both the original classification system and evolutionary classification. They're both really useful. It, it just, in some cases, uh, it's just neater to use the old classification system rather than split it up. And if you want to get all crazy and really focus on a specific clade, you look at it through an evolutionary classification kind of perspective. Okay, cladograms. This is your second question, by the way. What is a cladogram? A cladogram is simply a drawing that shows the relationships between species and larger taxa or larger groups by showing how they branched off from a common ancestor. So I'll pull up my cladogram of primates right now. All right. So you'll notice that this cladogram it has different branches to it. Okay, and it doesn't show all the species. Like for instance, um, when we have a branching off of a cladogram, this means that there was speciation. A new species evolved that was genetically distinct from an ancestor. So right here at this branching point, there was speciation that occurred. There was a new species that was separate from the primate ancestor, and its descendants later evolved into lemurs and lorises, and so on and so forth. Each one of these branches we refer to as a splitting point, a point where a new species emerged that was distinct from the old species, and later gave way to its descendants. Um, let's take a look at how we build a cladogram. So here is sort of a basics branch in a cladogram. This line that is going away from this branch is the ancestral lineage. So if you were to look at a cladogram of all life, it would be gigantic. Most cladograms only look at very specific monophyletic groups. In this case, the cladogram I showed you of primates only includes the descendants of that ancient primate ancestor. So they can be sort of narrowed down or broadened in order to include more evolutionary relationships. So like I said again, this branch right here is a splitting event, a point in which the ancestral species was divided into two new species. Okay, so let's go ahead and take a look and see how many splitting events we have for our primate cladogram. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 splitting events. There were at least 8 times uh, from the existence of our primate ancestor. There was at least 8 times in which it split off into two different species, at least 2 different species. Okay, so it went through a lot of different changes in order to finally become human beings, chimpanzees, and so on and so forth. Okay, let's get back to it. When we're looking at the different branches of a cladogram, every single endpoint on the cladogram is a descendant. So if I go back to my primate cladogram, these are all descendants of the primate ancestor, but uh, there is something to be said for how they're arranged. And they're arranged based on how closely they're related. So if you look at chimpanzees and humans, their cladogram, their branch, really is not too far apart. And they had the most recent splitting event. So the most recent sort of deviation, or sorry, evolution away from the primate ancestor species gave way to chimpanzees and humans. And it makes sense that since the split occurred so recently, chimpanzees and humans are the two most closely related to each other within the primate family. And you can see how closely related you are to these other species based on how far away they are, how far their branches are away from your target species. So we can see that we're most closely related to chimpanzees, but we're most distantly related to lemurs and lorises. So out of all of the different groups here, the prosimians, the anthropoids, and the hominoids, we are the most closely related to chimpanzees and the most distantly related to lemurs and lorises. We are still related, we just don't have as much in common evolutionarily and genetically with lemurs as we do with chimpanzees. Okay, so the distance between these branches is important when we're looking at a cladogram. Okay. Moving on, we have a sample cladogram right here on this page. Let me just double check the stream right now, make sure everything's working as intended. That's not it. Okay, there's the stream. I'm here. I'm related to. How are we related to lemurs? Well, Paris, it's a great question. We're related to lemurs because we had a common ancestor, most likely a tetrapod, and that common ancestor eventually split off and acquired specific traits that were passed on to all of its descendants, or it lost specific traits. Um, if I'm looking right here, let's go back to the cladogram. Right here, I'm not sure what would be the trait that was developed or lost, but we can see that what's one thing that we do notice about if we move from left to right? What do you notice about the traits as we move from left to right? Anything, Paris? Do you see the difference? I'll give you guys a minute. What key trait is different from the left side of this group? Tails. Okay, perfect. So we see that uh, we are losing the tail trait the farther right we go from lemurs to humans. Okay, this is an example of what we refer to as a derived character, a trait that either emerged or was lost as speciation occurred, as these splitting events occurred. So as we continue down this evolutionary line and these splitting events occur, we notice that some of the species that split off do not have tails. They lost that particular trait. Maybe there was no need for it. Maybe it was uh, um, not an adaptation in certain environments. And it's interesting. It's interesting to sort of track the emergence or the loss of traits as you progress down a cladogram and trace the evolutionary lineage. So we're related to lemurs and lorises simply because we share a common ancestor, but we are distantly related, as you can see from the difference in traits and also the differences in DNA. And we'll talk about how DNA is involved in developing these cladograms as well. All right, let's get back to it. Not this one, this one. So here's the sample cladogram that's given on page 434 of your book, and it's not too detailed. It's very minimalist, but nonetheless we can still use this to our advantage. Okay. So this cladogram shows relationships between vertebrates or animals with backbone. So every single one of these species here is a vertebrate. That's what they have in common. There was some ancestor that existed that passed on the backbone trait to all of its descendants, and it is that backbone that is the souvenir, if you will, the souvenir left over from that common descendant. sorry, from that common ancestor, and all the descendants here have that particular trait. Of course, these descendants all have very different traits as well, but the one they all have in common is a backbone, okay? So let's take a look right here. There must have been some species that had a backbone, some kind of skeleton, maybe a simple skeleton, and then it eventually, it existed and survived and reproduced, and eventually it got to this point. There was a splitting event here that led to a descendant that gave way to other splitting events, and then it also gave way to modern day sharks. What could this splitting event be caused by? Well, it could have been caused by environmental factors. It could have been caused by the evolution of a new species that put on evolutionary pressure to this ancestor. Um, and well, really, there's no way to tell exactly what caused a splitting event. Sometimes it also is random due to the nature of DNA and mutations in general. But you can see that every single one of these has at least the backbone in common. Now, whether they have other traits in commons, that remains to be seen. But from what I can tell in this cladogram, I can see that birds and mammals are the two most closely related on this particular cladogram. Uh, at least from the mammal standpoint, they are most closely related to birds. However, birds are not most closely related to mammals. They're actually far more closely related to crocodiles than they are to mammals. How do I know this? Well, despite the fact that birds and mammals are really close right here, we notice that one of my branches, one of my splitting events, gave way to more splitting events. Okay, so if I'm starting right here at this splitting event led to mammals, and it also led to another splitting event that resulted in turtles and birds. But before birds emerged, there was a splitting event that led to lizards, and the splitting event that led to crocodiles. So actually, crocodiles and birds are more closely related to each other than birds are to mammals. Uh, yes, we're related to turtles. Let me ask you guys a question. Do you have lungs? If the answer is yes, you do have lungs, and you're related to a turtle. Because what do turtles have as well? They have lungs. Okay, there are instructions. There are very specific instructions that lead to the development of lungs in living things. So, uh, based on those similarities and traits, we can say with confidence that we're related to turtles. No, I don't have lungs. I'm sorry, Aaron. I don't know how is do you diffuse oxygen through your skin? Oh my God, Paris. Okay. All right. So I mentioned this term derived characters. Well, actually, before we do that, let's go ahead and just recap what we see in cladograms. So the root of the cladogram, the very starting point, is called well that it represents the ancestral lineage or ancestors that came before that particular ancestor. So pulling up my cladogram here, there is an ancestral lineage here. This primate ancestor did not appear out of nowhere. It also had its own ancestors, but we're not focusing on those ancestors right now. Um, now, when we get to our splitting events, these branches where it forks off into two different evolutionary lines, we call this a node. Okay, each node represents a speciation event, so a splitting of one species into two new species. So that we can call them nodes, we can call them splitting events, we can call them speciation events. They all mean the same thing. Okay, and I'll highlight right here. They're called nodes. They're called speciation events, and they're also called splitting events. All mean the same thing. Okay. Uh, Now let's talk about derived characters. So derived characters are traits that arose in the most recent common ancestor of a group and were later passed on to descendants. So an example would be tetrapods. Tetrapods are a clade of animals that all have four limbs. So if you have four limbs, two arms, two legs, or four legs, you are in the clade tetrapoda. And all of the ancestors in the clade tetrapoda will also have four limbs. Um, if we're going down even further, hair is a derived character for the clade mammalia. So hair is a characteristic, a trait, a derived character that appeared in mammals. It didn't appear in all tetrapods, it just appeared in mammals. Um, and we know this because all mammals have hair, and that's what makes them a mammal. Well, that's one of the characteristics that makes them a mammal. Having four limbs is not enough to make you a mammal. There are plenty of animals that are not mammals that have four limbs. But if it was the case that mammals were described by having four limbs, then it would be only mammals that have four limbs. Okay? Are there any animals that have an odd number of eyes? Yeah, tuataras. I mentioned them earlier. Tuataras don't have even number of eyes. Okay. Now, derived characters typically describe traits that appear in a common ancestor, but they also describe when traits are lost. Okay, a great example of this would be snakes. Snakes, if we look at the evolutionary chart right here, I would say that where my mouse is right now is where tetrapods first emerged or arose. Okay, because ray fin fishes and sharks, those guys don't have four limbs, but amphibians do. Amphibians do have four limbs, so the derived character for four limbs would appear somewhere before we had a node or a splitting event that led to amphibians. So the trait for four limbs was present here, but what do we notice about the species in this group or in this clade, starting from amphibians? Well, snakes do not have four limbs. So what happened there? What happened to the four limbs trait? Well, they lost that derived character. Okay, they lost it and eventually split off and became their own sort of clade of organisms or reptiles with no limbs. Okay, but we got to be careful when we're talking about traits that are lost. Okay, because you can have really distantly related groups that can lose the same traits. So an example would be whales and snakes that's given in your book. They both lost their legs. Does that mean that they are closely related because they both lost the same trait? Well, no. No, it's an example. It's an example of convergent evolution, which we'll talk about later. We know that snakes are reptiles, whales are mammals. So if we just paid attention to the derived characters to make our comparisons, we would be very, very off the mark. Okay? So we're going to take a look at a cladogram in the book, and it's going to show us the evolutionary line of the cat family. So we're going to go ahead and take a look at it right now. Let me see if everything is being shown. Yeah, I think we're good here. So we start off with clade tetrapoda, the tetrapod clade, so organisms with four limbs. Let me see if I can undo this. No highlight. So we're starting off with the tetrapod clade, and every single member and descendant of the tetrapod clade will have four limbs, or if it lost four limbs, like snakes did, but it will have the trait, or at least the genetic instructions to for the trait of having four limbs. Anyways, so before amphibians arose, the ancestor of all of these species developed four limbs through some random event, maybe genetic mutation, maybe some other reason. But eventually we reach our first node with where we have the ancestor species splitting off into what later became amphibians, and the other species eventually split off into all the other species that follow. Okay? So, now we're moving on to the next clade. But before we get to the next clade, we have another derived character, another trait that appeared during this evolutionary lineage. Okay? And that would be the amniotic egg. So, an egg that has membranes. Not all animals have eggs with membranes. For example, fish don't have an egg with membranes, but reptiles do. And this species later split off Okay? And after the splitting event, there was a descendant that gave way to reptiles. And then there was a descendant that later evolved into all the species that follow. Okay? All right? So we have two derived characters. We have two splitting events so far that gave us two descendants, modern day descendants, reptiles and amphibians. Okay? Moving on. So the species that did not become later evolve into reptiles, it kept going, it kept surviving, and then eventually the trait of hair arose in that ancestor species. Uh, After that trait arose, a splitting event occurred later on, and one of those species that arose from this eventually evolved into modern day marsupials. The other species continued on this path and evolved into the other species on this list. Okay, I hope you guys are making sense of this. If I need to, I can find a sort of breakdown resource that walks through cladograms. Um, and so on and so forth. We're going to keep going. Uh, after marsupials branched off from the ancestral lineage, the ancestral lineage developed a new trait, a new derived character, and that would be specialized shearing teeth, carnassials. That's what they're called. And after that derived character arose, there was another splitting event that gave way to modern dogs and its relatives, and the species that did not follow that path eventually evolved into the Felida clade, or the clade of cats. And before they did that, they developed or they acquired the derived character of retractable claws. Okay, so what do we see here? We see that dogs and cats are the two most closely related species on this cladogram. We see how cats maintain all of these derived characters, okay? So one by one, these derived characters eventually were passed on to descendants until they were all kind of manifested in the cat's clade, and so on and so forth. So you'll notice that these species all exhibit the derived characters that arose before they came into existence. Okay. All right. Uh, so let's take a look at this specific example here. This is on page 435. And I'm going to try to draw a cladogram right now. Now, it's not going to look very pretty, but I'm going to show you guys how we can turn this information, turn this list of traits into a cladogram. Okay? So the first thing I'm going to do is I'm going to unhighlight this. And I'm going to take a look and see which organism is the least like any other. Okay? So if I take a look at humans, humans have a backbone, they have legs, they have hair. Okay? Lizards have a backbone and legs, so they have two traits in common. Trouts have one leg, or they have a backbone, no legs, and no hair. So we have traits in common with everything, with lizards and trout, but not with earthworms. Earthworms, unfortunately, we don't have any similar derived characters. So we're going to start making this cladogram with earthworms. Okay? Let me pull up a paint document right now, and I'll try to get this going. Okay, so I'm going to start right down here. Let me see, my brush is going to be big enough. I'm going to start right here. This will be my ancestral lineage. Okay, I'm going to put just ancestor right here. I'm not going to put earthworms because earthworms is a modern species. Okay, and I'm going to branch off from right here. So there must have been an ancestor at some point that had no backbone, no limbs, and no hair, but eventually there was a splitting point. Okay, so here's a splitting event, and what happened was one branch did not develop a backbone. It did. Oh, Actually, I gotta redo this really quickly. So there was a branch before here that ended up not resulting in the development of a backbone, forelimbs, or hair, and this later became earthworms. Okay, earthworms. Okay, so I was doing it right in the first place. Um, and so this particular branch eventually descended into earthworms, and the other branch that split off from the ancestor kept going this way. So we'll just kind of draw this out like this. Now, eventually, a backbone had to have evolved. Okay, there had to have been a species that was born and had, or developed a backbone due to some sort of mutation. So, at the point where that backbone first emerged, we'll put a little dot here for our derived character, and this will be just backbone. Simple as that. And what happened after the backbone emerged? Well, there must have been another splitting event, okay? Another splitting event that happened after the backbone appeared. We're not going to draw the branch before because we already have a branch that occurred before the backbone arose, and that was led to earthworms. So we're going to have another splitting event after the backbone arose, and it'll be right here, okay? Now, this branch, this splitting event led to a branch of descendants that eventually became trout. We'll put that right here. Perfect. And, well, okay, what happened to the descendants that did not become trout? Well, at some point in their lineage, a new trait arose, and that would be the trait for four limbs. Four limbs. So after this trait arose, there was another splitting event. Remember, it has to happen after the derived character appears, not before. Okay? Because if I draw it before, let me just draw it before. And I put, what was the example they gave us? Lizards? Yeah. If I put lizard before the derived character of four limbs, then it doesn't make sense. You're telling me that lizards do not have four limbs, or they evolved before the trait for having four limbs arose? No, that's ridiculous. So we're going to make sure that we put these splitting events after the derived characters. So after the trait for four limbs arose, there was another splitting event, and one branch of descendants later became lizards. And the other branch continued on as normal. They did not evolve into lizards, but they still had four limbs. And after that previous splitting event, there was another derived character that appeared in the lineage, and that would be the derived character of hare. Okay. So from this point, now that we have the derived character of hare, hare is now a new trait that has arose in our ancestral lineage. There was another splitting event. However, we don't need to write a splitting event here. Okay, we've already gotten three of the four species that we were trying to map out on a cladogram. The last one being humans. Okay. Now, this is the cladogram based on the information that we were given in this section. Okay, so right here we did a cladogram that shows all this information. We included earthworms, trouts, lizards, and humans, and we see them on this cladogram along with the different traits, the different derived characters that they acquired over the course of their evolutionary lineage. Okay. But we can add more to this cladogram. I mean, I don't see why we can't, right? Um, so let's go ahead and add something else. What else can we add before humans? We could add another branch here. Let's go ahead and say that we added. Let's add a branch right here. Okay. Or actually, it's probably better if we add it over here. No, we'll keep it right there. Uh, so right here, we can have another derived character after this splitting event. Okay. And this derived character could be something like prehensile tail. Let's put a prehensile tail here. Oop, prehensile tail. That just means a tail that can like grip things and grasp and wrap around things. A tail that has lots of dexterity. So this prehensile tail is a derived character that gave way to let's just put howler monkeys here. Oh wait, howler monkeys don't have tails, do they? Oh, just put lemurs. I don't know if lemurs' tails are prehensile, but they definitely have tails. Um, okay, so we can see that the branch that led to humans did not have the derived character of prehensile tail. The derived character appeared after the splitting event that led to lemurs and humans. Although I'm pretty sure that the tail trait probably appeared earlier in this lineage. But you can see we can add far more different splitting events to this cladogram and make it really comprehensive. But you don't need to do that. Oftentimes, when you're looking at cladograms, you're just looking at a specific sort of lineage and not really including anything else that's not relevant. Okay? Okay. Let's talk about the differences between our clades, our cladograms, and the traditional groups, the Linnaean classification groups. So, luckily, Linnaeus and others, his predecessors, were actually pretty good with their classification. A lot of the organisms that they classified as being in a single group are also true clades, meaning that they're monophyletic. They include an ancestor and all descendants. So some of the groups have been pretty accurately classified. An example of one that is not, again, is reptiles. Reptiles has species that do not share common ancestors. Um, but mammals, fortunately for Linnaeus and all of his colleagues, uh, class Mammalia is the same as the clade Mammalia. All right, so they did a pretty good job right there. In other cases, like for instance, reptiles and birds, they are not true clades. So in traditional classification, birds and reptiles were put into two different classes, aves and reptilia. But research shows that reptiles are all descended from a common ancestor, and birds are also descended from this ancestor. So without birds, class reptilia is not a clade. You got to put those two together to make it a clade. Okay, and we'll go back up here just so I can show you. We can see right here that, yeah, birds, they share an ancestor with all these. So reptiles probably split off right here during this node. Okay, so this is the node where reptiles eventually split off and became their different groups here together. So birds are part of that particular clade, but they used to be distinct. They used to not be included in this group of animals, but the genetic evidence shows that they actually are related to all reptiles and they do share a common ancestor. So that's an example of where traditional classification was off the mark. Okay. So let's talk about DNA and classification. And I think your last key question was, where is it? How are DNA sequences used in classification? Okay. So that's our final key question that you guys are going to have to answer. How is it used? Well, you guys have heard of DNA testing, right? You guys have heard of things like 23andMe, just websites and companies you can send a sample of your DNA to, and they can sort of see what your family tree looks like with all your ancestors and who you were descended from and all that. The same thing is used in classification, at least modern classification. Uh, DNA again is simply a substance that controls traits. It's composed of sections called genes, which control traits in organisms. and those traits are passed on to descendants. So everyone who everyone who is descended and part of the same species, descended from an ancestor and is part of the same species, will have very similar DNA with little variation. Okay, but over time, uh, due to other splitting events and genetic mutations, the differences in DNA can grow. Like for instance, I'm pretty sure our DNA was very similar to lemurs. Our ancestors had very similar DNA to the ancestors of lemurs, but through time and evolution, our DNA changed more and more and more as we developed into our respective species. So comparing how similar genes are is sort of like a clock. It's like a clock. The more similar the genes of two species are, the more recently they shared an ancestor, and the more dissimilar they are, the further well, the less recently they shared a common ancestor. So a good example would be hooded vultures and American vultures, despite looking very similar, okay, despite having very similar sort of body structures and appearances, they're actually not very related at all. They're not closely related. In fact, uh, American vultures are more closely related to storks genetically. Um, so what does that mean? Well, means a couple of different things. It means that, well, having certain vulture-like traits in certain environments is very helpful, but it also tells us that we can't just rely on appearances alone to group these animals together. We have to take into account uh, the similarities in their DNA, the similarities in their genes. And after doing so, we can really sort of trace these evolutionary lineages more accurately. Okay? So how is DNA used in classification? Well, in general, the more derived genetic characters that two species share, the more recently they share a common ancestor. So when they say derived genetic characters, they just mean the more genes that two species share, the more recently they shared a common ancestor. Okay? And it is this form of classification using DNA that revealed to us that giant pandas and red pandas are actually not really closely related at all. In fact, giant pandas are more closely related to bears. Their DNA is more similar to bears than they are to red pandas. And red pandas are most similar to raccoons. Their DNA is more similar to raccoons than it is to giant pandas or bears. And that's how you can, look at these cladograms in a different sort of perspective, looking at them in terms of DNA. Okay, I mean it's fun to go in and look at sort of just the emergence or the loss of traits and trace your lineage that way. But I always look at it in terms of DNA. Okay, so if I'm looking right here, the DNA of lemurs and humans is are more similar and have more in common than the DNA of humans and lizards. Why? Well, just because they branched off later than lizards, okay? And they're closer together on this cladogram. All right. So uh, once again, let's go ahead and answer our key questions. I'm going too far. Yikes. So, what is the goal of evolutionary classification? The goal is to group species into larger categories that show lines of evolutionary descent rather than just similarities and differences in traits. Okay, so we're looking at ancestral lineage with evolutionary classification. What is a cladogram? A cladogram is a diagram that shows and links groups of organisms by showing how they branched off from common ancestors. And finally, what is or how is DNA used in classification? Well, in general, the more similar, the more closely similar two species DNA is, the more recently they had a common ancestor. And the less similar it is, the less recently those two species have a common ancestor. Okay? So that about wraps us up here. I'm going to I'm going to go ahead and do an attendance check. So right now, I need everyone to go onto the Google Classroom page. I'm going to put a little post right here. Yikes. Attendance check for 323. And the keyword for today will be cladogram. So put cladogram and your name and comment on the attendance check post, and I will go ahead and mark you guys as having made it. And what I would like you guys to do right now is to go into classwork and answer those lesson questions that we went over. Okay? I'm going to go ahead and put myself on mute, but I will keep my chat open so I can see if you guys have any extra questions. And if you guys have any questions later, you can't access. Uh-oh. Aaron, you're unable to get to the Google Classroom? Just type in here. Just go and type Google Classrooms in the search bar. And it'll take you to this page. You can just open up a link on the Google search right there. classroom.google.com. And you're good to go. Yeah, so if you guys still have work to turn in, just get it in as you're able to, as you finish it, just so I can keep giving you guys credit. Again, tomorrow I'm posting the corrections for 18.1 and 18.2. And if you submit an assignment after I release the corrections, it will get late credit. Okay? Let's see. So Paris was here. Who else? I know I could see Matt. I know Tristan's here. Ethan's here apparently. Very nice. Just go ahead and get to the Google Classroom page, write cladogram, that's the keyword, and then your name. Garrett, you don't need to be here. This is third period. You have to be here on tomorrow. We're going to do another lesson. And you're part of fourth period, so go to that one. No need to come here. All right. Yeah, unless you guys have any more questions, class, at least this stream is over. And I'll let you guys get started on those lesson questions. Again, if you guys want to answer them, just go to the classwork, and they should be the most recent classwork assignment posted. And go ahead and answer those questions right there. Anything else? All right. that'll about do it. So I'm gonna close the stream right now. Thank you guys for coming out and being a part of the lesson. Again, if you have any questions that come up later, just email me or post on the Google Classroom page, and I'll get it and I can address it, as it comes up. So take care, guys. Hope you're doing well. Miss you guys. I hope we can get back to school soon, get back to the classroom soon. So, without further ado, I'm going to go ahead and play myself off. Take care, guys.